Okay, this is going to be problem describing what we in class would typically call a type 1 problem when we solve radicals. So this is the problem that we're going to start with. Now keep in mind as I go, if I'm going too quickly, please just pause the video. Please also make sure that you are actually writing down and listening to the video. It's really helpful to actually hear the explanation of why I'm doing things. Just having one example isn't necessarily helpful to do the other problems, but if you hear why I'm doing them, that can be helpful so that you can generalize those steps and apply them to other problems and big ideas. So our goal still is to solve. So we are solving equations. We're trying to get this x by itself, but there's all kinds of barriers in the way. We've got that 3 in the front, we're adding 3 to it under the radical, it's under a radical, and we're subtracting 2. So we've got to get rid of all of those obstacles. So in order to do that, we're going to do the reverse of order of operations. This is always how we solve equations. So the reverse, we would start with getting rid of this 2 first. So we need to move it to the other side because we're trying to get the x by itself. This is going to be our first step. So I'm going to add 2 to both sides. And the reason I'm adding 2 is because it was already being taken away. So this is going to cancel out, and I'm going to be left with 3, and I've got a square root of x plus 3, and on this side I now have 24. All right, so I'm one step closer to getting that x by itself. Now, we've done an addition or subtraction. Now let's see if we need to get rid of some multiplication or division. And we do. We've got this 3 right here that we're multiplying. We need to get rid of it on this side. So it's being multiplied by the radical. And to undo that, I need to divide. So I'm going to divide this side by 3. And what I do to one side, I've got to do to the other to keep it balanced, because it is an equation. Now, the reason we did that is because 3 divided by 3 gives us 1. You don't have to write the 1. We just write x plus 3. And on this side, I've got 24 divided by 3, and that is going to give me 8. Okay, so still trying to get an x by itself. Now I need to get rid of that radical sign. And in order to get rid of the radical sign, I'm going to square both sides. Because remember, when I don't have an actual root here, it's a square root. So it's like an invisible 2. So to undo taking the square root, we are going to square both sides. So I'm taking that to the second power, and I'm taking that to the second power. And the reason we did that is because it completely gets rid of that radical sign. So I've got an x plus 3. So notice how it's all gone, but the stuff under the radical has not been affected. It just dropped the radical. And on the other side, 8 squared is 64. Okay, now we're to an equation that you know how to solve. This is a one-step equation. Now that I've gotten everything out and I've broken that x term out of the radical, it's now free. Now I can do some other things with it. So I need to get it by itself. I'm adding 3. To get rid of that, I'm going to subtract 3 on both sides. And I've got 64 minus 3, which is 61. Now, here's the thing about these kind of problems. This is the original problem up here. This had a square root. So that means we have to check our answer. Now, this is a part where usually in class people get really mad, but we're going to have you do it somewhat differently because we have access to Desmos and we're going to have you use that. So what we're going to do to check your answer is that you are going to sub in this 61 anywhere you see an X in the original problem. And we're going to simplify that side to see if it equals that side. So I'm going to go to Desmos. All right, and the original problem, I'm going to type it in here so that you can see. This is my original problem. Now notice when I get out of here, I need to space over. I can't just do the -2. See how it's still under the radical sign there? I don't want that. You got to space out of there. Make sure that -2 is not under the radical sign. Okay, so this is one side of the equal sign, and 22 is the other side of the equal sign. We want to know if I sub in 61 right here, does it equal 22? Yes, it does. Now, the reason I showed it like this is because sometimes you'll have to check that it's not just a number over here. It could actually have other variables. So you'll have to sub in maybe the value of x into both sides. But we can see here that we have a match. So 22 and 22. So that means, by definition of a solution, if I sub it in and it makes an equation true, that 61 is a solution. Okay, so now you're going to practice some of these on big ideas.